Hello guys, I have given link of the data sets and the notebook in the description. So check it out and run it out. Run it out and take the references if you need. This is it. So let's continue the video. Hello guys, today we are gonna go do classification problem listening, which is fake news classification. We are using by LSTM listening RNN and we are trying to classify the fake news, isn't it? Fake news, isn't it? This is our data sets, isn't it? Data sets. This is a training.csv and we have three files, isn't it? We are gonna be primarily using this train.csv file, and this is our some necessary libraries like pandas, numpy, matplotlib, cbon, and regex and ltk and other things. So this is our necessary libraries, and we are just try to classify this we have two levels, I think two levels. One is zeros, and you can just I am reading the csv file, and we are reading the csv file and storing in this data frame. As in, I am showing the head as in head. This is our head as in head of a this is our head of, and this is our text in text level. As in, we are just using these two columns. We are just we are just forgetting all these other column like id, author, isn't it? We doesn't need, we just don't need text and label column, isn't it? So we are first, let's see the first title, isn't it? First title of the, this is our first title, isn't it? And this is our first text, first news, isn't it? First news of this title. This is the first news, and then I am just displaying the info of the data frame, isn't it? Info of the data frame. There we have, isn't it? Mm, ID is in ID title. We have just, you can see that there is not equal. There is a different numbers of ID, title, author, text, labels, and so we have to remove all the non values because we need because we will not process the NaN values, so we have to remove the NaN values. First of all, drops the unnecessary columns. Any unnecessary columns like ID, we doesn't need it, title, we doesn't need it, author, we doesn't need it, and we are the axis one means we are removing the column, not the rows. Any, so we removing the axis one, so dropping the columns, these columns, isn't it, from this, and we are dropping a nan values from the axis is equal to 0 if any of the row contain any of the nan values except then this isn't, because we have already removed this isn't. So df contain only two columns, isn't. One is text and one is label, isn't. If any of any of two isn't test, if any of two have a nan values, then we'll remove that rows in a row from axis 0 in 0. And we are just we are just this is a new data frame, and just we are just knowing the information, isn't it? You can see that we have equal numbers of data points for text and label and so forth. And this is, and we are just moves on to the data preprocessing part, isn't it? The preprocessing part, what we are gonna go do here, isn't it? This is our stop or this is our analytic case, analytic.corpus. I will run that, so it will running. So I will run it, isn't it? So I'll run it. Go to the GPU section. I have enabled the GPUs in it. So let's run the code, isn't it? Running in the meantime, isn't it? So let's see, isn't it? This is an analytic.corpus import stopboard. We're importing stopboard and stopboard.o.english. We are just using the NLT and natural language toolkit and corpus. We are importing stopwords and creating the list of possible stopword from the analytical libraries, and we are listing this stop list. This stops will contain the list of stopwords. And stopwords means, I think, which doesn't have a, like a and e's and this a e's and other like a e's and r and any ss, and we are just removing all necessary. What is stopword? I will show you the stopwords. What are the stopwords in it? What are the stopwords and stopwords? It's running, so I can't run it because it's running down below, down below. So I will. It means we are containing the stopwords. It means which out we are just grammar, and these are the is, mr, and all other are the stop words, and all those and the and etc are the stop word, and we are creating a function, isn't it, to clean the text, isn't it? This function we're gonna go using this function, isn't it, below, isn't it? We will gonna go using this function below. So mm, this is our, isn't it, function. This is our function. And what we are doing here in the in this function is we are just defining the clean text txt, and we are just lowering the text and removing the stopword, isn't it? Forward in text dot forward in text dot split, forward in text dot split. We are splitting, lowering it and splitting it into the list. And if any of the items any of the word in the slits, if not in the stop was any, um if any of the word is not in the stop word is any, so we are joining into the txt is in, joining into the txt is in txt file. And we are, this is for loop, we are going through the each of this, we are just splitting the text and checking whether it's this word belongs to stop word or not. If not, we will join it and look at here. And we are removing the non-alphabetic characters. Non-alphabetic character means A to Z and small h to capital H to 0 to 9 and slash space and space. Mm. If we will remove all this, is avoid this, and we can just remove it, the slash s is in. So we can remove it. So except this character, we will remove all of this, isn't it? All of this, I think, with numbers. I think we know we can just remove the numbers. I think numbers we can just remove it. So we just write capital H to Z, and other than that, we'll removing all of these with empty space, and we are just substituting space with this. We're just removing the backspace and backspace and removing it. We can just remove it, just removing it, and we're just removing the spaces. And let's move on to the text. We are returning text. We are returning text, and this is what we are calling function here, the clean text function. Applying the text cleaning function to clean the final news values in. So this is our text, and we are applying it to the all of this text, and we are just clean text, and we are creating the new. This is our text, new clean text. You can see there is no apostrophes and any other any other things in it. So you can just, I will just remove it. You will see it is, we are just applying these functions in clean text. It's running below, so it will not run right now because I've already run it. So and let's do the tokenization part. We are applying these functions in clean text function. We're cleaning it and storing into the df.text by calling these functions, and by calling this function clean text, we are applying it. Here we are applying it, and this is our clean text function, isn't it? So from keras to replacing import, for keras replacing text import tokenizer, and what we are doing it here. And then we are using three keras replacing the text import tokenizer, importing tokenizer, and importing path sequences from keras to replacing dot sequence, and we are tokenizing text. What does this mean by tokenizing it? And converting text into numbers, we are converting text into numbers. That's tokenization. You can understand it, isn't it? Let's see, isn't it? We are tokenizing that feed on text. We are just feeding all the text. And od index is equal to tokenizer dot od index. Uh, is the od index, and then uh, vocab size is equal to length of word index, and vocab size and vocab. What is word index? Word index means this. We're assigning the text with this values. I will run it. It's not work because I am running below. So we are just giving the set to two, yes to one, niyama to three. We are just giving the tokens for each word, and for each word, and we are giving that person, and this will o dot tokenizer dot od index gives the gives the index, and it gives the index for each of these text, and we are just taking the length of this tokenizer or index, and we'll get the vocab size, because uh for every different word it will give that, it will assign the number for each different word, isn't it? Each different word, and then this is the vocab size, and we are printing word index. You can see our word index. This is our word index, and we are padding data, isn't it? Because, and then let's see, isn't it? This is our word index, and let's move on to the next part, isn't it? And we are converting text to sequences, we are just converting the whole text, isn't it? Whole text was first taking, for example, this news of this text. We're converting into the, I will show you. We're converting into print. Let's see. I am converting into text every news, isn't it? Every news to sequence. I will show where one news finishes. I am converting the text into sequences. You will show it, isn't it? This is our first news. Where is our first news? Let's move down. Let's move down. This is our text. I'll show you. I will show you what here is in here. Just converting the text into every news into a numbers. Here here we have to just, this is our first news. This is our first news. I think where that's end, isn't it? Where it will be ending here is, and I have to just go through it. So wait it. I've seen it where it ends. To find it, but there is a listing. We are just separating the list. We have multiple these types of list, and another list. Another list I will show you. What? It will take some time. See here. This is the next news. The next news, and this is the next news. We are just convert. This is the next news. And every news has been sorted over. This is the next news. We are just converting the this whole news. Whole is numbers into is a news. Is a news from here. From here to up to here, where we have to find another this brackets, and so below, and this is the first for first up to here, I think, and then there the next news is started here from here. Next news is started from here, and there is some another one news finishes. Then we have just list of these items, and list of these items from here. You can see it. We're just converting the whole news into these numbers, isn't it? Just in form of numbers. We are representing it from here. This is a third news, I think it's third news, and this is whole news. We are just converting the news into the such numbers in such a beautiful. Hmm. We're just converting into numbers. You can see it. There is. We are just. This is news, and this is the news. This is the third news, I think. There are many news, so you can see that this is the news. We're just converting the news into the text and text to understand, to get the idea. Uh, where is it? Let's see. Or index. We are what we are doing it. We are sentence length, isn't it? Sentence length. We are giving the for every sentence. News can be a thousand word, a thousand word, or sentence length can be thousand or 600 or 700. What we are only considering 5,000. It's enough, isn't it? It's enough, isn't it? It's enough 5,000 to get the insights of the news. So what we are doing here, we are just converting the each of the text of into this sequence. We are just converting, just tokenizing text to sequence. We are just converting text to sequence into all of this all of this item of this df.txt. I'm converting into sequence, text to sequences. So this is a sequence. And I'm printing the sequence and printing the sequence. This is the sequence. This is the sequence. And we are doing for each and every row of the text, and so we will convert all the news into the numbers. So because our machine learning models can only understand numbers, or it is very easy to consume for the model and consumable for the model. Then I'm printing it, and what I'm doing here is I am just making the length of each news equal, because this news from which started from here and end somewhere there, I think somewhere below, and each of have a different lengths, and you can see each of this news has a different length, this news has a different length, and this news has a different length. So make the, because we have to make the size of every input to the model is of equal size, so this has a different length, and above has a different length. This news from here to here, this news have a different length, and this news has also a different length, isn't it? Different length. So every news has a different order, isn't it? Order, and we have given the numbers to each of these words, so we have different length, isn't it? So for the model to understand and consume, isn't it, we have to make, isn't it, each of the sentence of equal length, isn't it? So, so what I'm going here to do is I am just printing, just I am where is it's below there. I'm just converting. I'm just padding. I think what is the max length of the max length? We are just taking a 5,000 order, 5,000 order every news, and this is our sequence. This is input, and we are just padding with post, is in post. We are just do zero padding, as in if certain news is small, or if certain news doesn't have a 5,000 words, so we will pad, we'll pad by zero and make the size of 5,000, for each input vector for the model, so, and if some news content more than 5,000, we are truncating, means we are removing from the post, from we are truncating, we are removing it from the post, was that's the padding part, and our data is, I think, consumable, is we are converting the data into numbers, and which will be easy for our model to mostly process and extract the features in it. I think this is a beautiful part, isn't it, for converting, isn't it, numbers into text. It's such a interesting part. And let's say C, isn't it? We have the each and every news of equal length, isn't it? If some news hasn't have short small length, we are just adding with zeros. We just want to know more, isn't it? So we're just adding by zeros. If some certain news has a small length, isn't it? So we are adding at the post, isn't it? Post by zeros, and making the equal size for every news, so if some news has bigger length, we are just truncating from the post and making the news, of equal length, so our model, can feed it. And what we are doing it, we are just, this is our X, I think this is our training data as an X train. This is our news, and we are have df dot labels. We have, for each of this we have labels. We have also already we have numbers, 0 or 1. Zero means what's our zero level? We can see here, labels. We are just zero. Just to give two classes, 0 or 1, isn't it? Zero means, I think, fake news, and 1 means right news, isn't it? We can try it, isn't it? It's the same logic, but yes, I think zero. I think zero means yes. It's that. We can also check the levels, isn't it? You understand the idea, isn't it? Cool idea. What am I going to go doing it, isn't it? So we have two labels, isn't it? It can be zero means it can be. We can just label it anywhere, isn't it? We can just label zero as what is given in the data set. We have to see that what is given in this data set. So this is our labels, and this is our patch sequence and patch sequence. And here, here you can see it, doesn't it? See it? X padded sequence and df dot labels. And this is we are just splitting the data set, and padded sequence means X news is, and df dot label means the if news is fake or label is also in the integer form, so it will be easy for the model, so we don't have to convert into the numbers, it is already in numbers, so it's very easy, isn't it? We are just splitting it, isn't it, by 20% to testing part, 80% to training part, is training that validation part, 20% validation part. and we are just random state of 42 means if we put random state equal 42 next time listen, it will be the same sequence isn't it? All data will be arranged in that sequence. You understand it? And we are just creating a model listen here. We are getting this model listen. We are using bidirectional LSTM. Listen. It's a model training isn't it? Here what are you doing, what are you going, we are just from keras.clear we are importing LSTMs long sort of memories, dropout dense embedding bidirectional listening. From keras where I'm importing sequential model listening, and these are embedding vector dimension listening for every, or I will say using what is embedding means I will explain later on listening. This is our embedding feature vectors and vector features, and this is our model one listening. We are just initializing with sequential, we are getting a sequential model means we are just passing the data listening, from one layer to another layer sequentially in sequentially, not we are just combining. I think there's also functional APIs in functional models and we can made it, but it's a sequential but one model, one data goes to another layer and another layer. This is sequential one, sequential part. And this is our embedding layers. And embeddings means I think for each of the token we are just converting into the dense vectors. And dense vector means which is a better representation of the words. We're converting each word as it's a dense vector means converting the each word into a dense vector. We have a sparse vector means which have zeros in it. Oh, we have padded with zero. You above you can in the above you can see that we have, if text has small length we are padding by zeros and zeros. So it is not it will not capture the semantic meaning of the text and semantic meaning of the text. So it the embedding layer converts into the dense vectors in which has a better better, which is a better representation than sparse vector what you have defined earlier I just padded with the zero if the length, if sentence length is small as we padded with the zeros so it's not a better representation. So we are converting each tokens, it will convert each tokens into the dense vectors. And above we have the sparse vector, we are converting to dense vector because dense vector is a better representation. So it will capture the semantic meaning of the text. That's the like, property of embedding layer. And input length will be the sent length, which I have defined 5000. And we are just using LSTM models in LSTM with 100 nodes and 100 nodes in it. And this is our, we are just applying the bidirectional wrappers over the LSTMs in LSTM. So bidirectional wrappers. Bidirectional mean data can flows and data is flowing in both directions in data. I think the processing is happening in bidirectional voice. Bidirectional for some we are just bidirectional listening for every bidirectional which I am reading the text from both sentences. I am reading from here and I'm also reading from yours and here is I'm just processing it. It's a bidirectional. I am going from here and I'm going from here because I'm going from here because some sentence it's better to have just making the assumptions and prediction by just going from here. It's not a better just by from going in one direction, isn't it? So if I go from both directions, isn't it? Both direction, I can capture much more meaning, isn't it? Which will help to classify our news, isn't it? I'm going and capturing the meaning, isn't it? If you are just going from here and you will capture certain context from this way, isn't it? If you are just going from there, you will capture the whole context from here and here, isn't it? So it's better to use bidirectionals LSTM. So I'm adding dropouts and dropouts of 0.3 and 0.3. What dropout means? I think you know it. Dropout means I think just I'm just leaving the 30%. Just I'm leaving the 30% off, offing the notes of 30%, 30%. For the notes, I'm just closing 30% notes, and I am just having the dense because we are doing binary classification news fake or unfake isn't it? Or fake or real news isn't it? So at the end isn't it, I am just having an activation function sigma I isn't it, for binary classification and I'm having a one node and I'm compiling this model with binary cross entropy and using optimizer as atom and I'm compiling model with matrices like accuracy and I'm seeing the summary of the models what I have created sequential one we have embedding one bidirectional one dropouts dense We have this number of trainable parameters, isn't it? This is the total parameter train. Oh, we have all trainable parameters. We are not fine tuning the pre-trained model, isn't it? So this is this. And I'm compiling it again. Isn't it? I think I've compiled already here, isn't it? So I just need to compile again and again. So just I'm just doing it two times and two times. Just I remove it, and then it doesn't need this now. Then this is our and epochs. I have trained the models in here for you can see. I've already trained because it takes so much time for training me. Isn't it? So train the model where I'm just history and model one dot feed x train y train epochs for 10 batch size 256 validation data x test comma y test and I am running for 10 epochs so and I'm getting a pretty good accuracy of 99% for the training data and for 95% for the validation data and for validation data is I think our model you can see that when there is a difference between accuracy and validation accuracy of 10%, we are what's happening we are 99% and you're 95%. What's the differences? I think nearly I think difference of 4 to 5% is so if the model has less than 10%, you can consider the model is not overfit. Is overfit means it can also perform well for other data which are not included in the training as a training. So I think we are getting a 99% accuracy and validation accuracy of this 95% accuracy. Validation accuracy, and this is our loss plot. We are getting a pretty good. This is our loss. We are just going exponentially with for training as in training, and this is our training accuracy. We are getting good accuracy curve, and this is our loss curve. I think this is. I think what's the difference between loss? I think 0.0048 0. We can just improve on loss matrix. We have to improve on loss matrix. So we have to work on it, doesn't it? How can we do it? Just let's think on that, isn't it? How can we do it? Doesn't it? How can we improve the loss? I think you can improve the loss. I think by L2 normalization. So normalization. We are just importing some batch normalization. We just let's try. I don't know, but just we can do batch normalization here. See, model dot add batch normalization. You just do it, and it will reduce the accuracy. Isn't it? Batch normalization. We can use batch normalization and L2 regularization, and that's regularization. We can use regularization and some hyperparameter tuning and some changing the values from here, and adding some extra layer and just experimenting it and we can I think we can reduce to significant amounts and this is our loss plot and this is our curve is for good for loss. Let's see for loss. This is our loss plot so I think it's good as there is always you can just try. I will give you the I will give you this notebook and you have to just fine tune it, isn't it? Not fine tune it, but you have to just changing some parameters, add some extra layer, and just do it and just and see what's happened. And I will share the notebook with you all guys. And so let you do isn't it? Let you do your work, isn't it? Let this is homework for you, isn't it? Homework for you. So do your homework properly, and that's it for this video. And I will give you the link of this datasets. And this dataset, I am before going that I will just explain where I got these datasets. I will just give you the link of this dataset in my YouTube video description. So you will see that where I have get this dataset. I will just give you the link of this dataset. So don't worry, it's okay. So for this is just for this tutorial, isn't it?